everyone, welcome to my YouTube channel. I am again in front of you with the lecture of class 12th. Today in the lecture of class 12th, I will start a new topic, that is continuity. What is continuity? Continuity is we have to check the continuity at 2 points, like one at a point and the second one is in an interval. Okay, so first is continuity of a function at a point. We have already studied about the limits exist or not exist in class 11th in the chapter of limits and derivatives. Okay, the continuity is related to that topic, that limits. Okay, we have a definition of the limit, that limit x approaches to c, f of x is equals to f of c. If it is possible, then the limit exists. The continuity has the same definition like that. Come to the definition of continuity. Continuity of a function at a point. A function f be a real function on a subset of real numbers. Okay, any function f that is on a real numbers, and c be the any point in the domain of f, then f is continuous at c. F is continuous at c if x approaches to c of fx is equals to f of c. Okay, or one of the more definition, that this c is, this part is divided into two parts. First is left hand limit, second is right hand limit is equals to f of c. The left hand limit having c negative, that does not mean the negative value of c is there. That means it means c touched at the left side, little bit in the neighborhood of c, left side of the neighborhood of c, and this is c positive, it touched the right. Let us suppose we have the c here. C negative means we have to touch the left side of in this neighborhood, and this is the right hand side of the neighborhood of c. So we have to check on these two limit, left hand limit, right hand limit, that will equals to the f of c. Okay, so this is the definition of a continuity of a function at a point. If we talk about the intervals, there are only two type of intervals. First is open, second is close. Okay, when the function is continuous at open interval, then if the only f is said to be the continuous in the open interval if f is continuous at every point in this interval. At every point, if it is continuous at every point from a to b, then it is said to be the continuous function in the open interval. In the closed interval, three conditions should be satisfied. First is the function should be continuous in the open interval. Okay, the second one is left hand limit will also exist. Third is the right hand limit exists with the right part of that open interval, that the second number. This left hand limit will exist at b and right hand limit will exist at a. Okay, if the function implies the satisfy these three properties, then we can say that the function is continuous in the closed interval. Okay, so this is the definition of the continuity. Now how we can geometrically, what is the geometrical meaning of the continuity? Come to the geometric meaning. When we draw a graph at a point or an interval, there is no break in the graph, then we can say that the function is continuous. Okay, the geometrical meaning means, the geometrical meaning of the continuity, that is geometrical meaning of the continuity, there should not be any break. There is no break in the graph. I will write only. If you talk about the point, so we will take the point. If you talk about the interval, then we will take the interval. Geometrical meaning of continuity. Meaning of continuity. Continuity means there is no break in the graph. No break in the graph of the function. If you talk about the point, then the function is at that point. Okay, if you talk about the interval, then in that interval there should not be any break in the graph of the function. This is the geometrical meaning of the continuity. Now come to the discontinuity and its type. What is discontinuity? When the function is not continuous at x is equals to a, then it is said to be discontinuous at x is equals to a. So discontinuity and its type and its types. What is discontinuity? If function is not continuous, I will write the short form of continuous. If the function is not continuous at x is equals to a, then it is said to be discontinuous. It is said to be discontinuous. Continuous at x is equals to a. Its types are as the following. First is removable discontinuity. I will write the short form of discontinuity. Removable. When the limit x approaches to a, negative fx is equals to limit x approaches to a positive fx not equals to f of a, then we can say that when these two are equal but it will not equals to their third property, then that it will not equals to the third one, we can say that it is a removable discontinuity. By changing the number we can equate the function. That's why it is known as removable discontinuity. Now come to the second type, that is discontinuity of first kind. Discontinuity of first kind. When the both are not equal, limit x approaches to a negative fx not equals to limit x approaches to a positive fx. When these two limits are not equal, then it is said to be the discontinuity of first kind. These two are not equal. Now come to the discontinuity of second type, that is discontinuity of second kind. What is the meaning of second kind? If at least one of the limit x approaches to a negative or limit x approaches to a positive fx does not exist, then it is said to be, it is discontinuity of second kind. Okay, so this is the second kind discontinuity. There are only three types of discontinuity. First is removable, when both are equal, third is not equal. When this is discontinuity of first kind, when first two are not equal, and the second kind says that at least one of the two limits will not does not exist, then it is the discontinuity of second kind. Either this or this does not exist, then it is said to be the discontinuity of second kind. So this is the discontinuity. Now I want to tell you continuous functions, how many continuous functions are there, and where that function continues on its domain or everywhere. I will tell you about the continuous function. So come to the continuous function. Which type of functions are continuous? I will write the only continuous functions. Before starting this, I will tell you which functions are composite functions. Okay. The functions which are continuous on its interval or everywhere, write down the continuous function. Continuous functions. How many functions are continuous? First is constant function, a constant function, polynomial function, exponential and modulus. A polynomial function, exponential function, a continuous, a constant, a polynomial, exponential, modulus function. These four are continuous everywhere. Polynomial function, these four are continuous everywhere. Okay, so these are the four functions which are continuous everywhere. Second, a rational number rational numbers is continuous in its domain. Okay, the logarithm function. Third is a logarithm function is continuous on 0 to infinity. Okay, the open interval 0 to infinity. Trigonometric functions are continuous in their domains. So these are the functions in their domains. So these are the functions which are continuous everywhere on its domain in 0 to infinity and domains. Trigonometric functions are also continuous in their domain. These four functions are continuous everywhere. Rational function is continuous in its domain. Logarithm function is continuous only in this open interval, only for positive values 0 to infinity, but not including 0 and not included infinity. Between 0 to infinity it is continuous. Okay, trigonometric function is also continuous in its domain. So come to the continuity of composite function. Okay, this is the last introduction which I have to given to you. Continuity of composite functions. When we can say that the fog is continuous, fog combination, composite functions, that is the combination of two functions. Okay, so let us do the equation. Composite, continuity of composite function. Composite function. What is the continuity of composite function? Let f and g are real valued functions, right? In class 11th we will talk about only the real valued functions. G is continuous at x is equals to a, and f is continuous at GA. Okay, then we can say that this implies fog is also continuous at x is equals to a. So this is the continuity of fog function. If f is g is the continuous at x is equals to a, and at putting the value of a, the function which we get f is continuous on that function, we can say that fog is continuous at x is equals to a. So this is the definition of continuity of the composite function. Now come to the exercise. How we can prove this function is continuous or not continuous? How we can check? So let's start with the ncert. So we have the first question of exercise. The first question from your exercise, I will take the exercise 5.1. What is the first question? Exercise 5.1. The first question is prove that fx is equals to 5x minus 3 fx minus 5x minus 3 is continues at x is equals to 0, x is equals to minus 3 and x is equals to 5. So this is very easy question. In the 3 points we have to check the continuity of this function. I will go through the first definition which I have write down at a point at the first position. I go through with that definition. What is that definition? Let us start with the definition. The definition says that if I talk about x is equals to 0, limit at x is equals to 0, limit x approaches to 0, f of x, that is limit x approaches to 0, f of x is equals to 5x minus 3. When I put the value of x, that is 0, put the limits, that is 5 0 minus 3, that will equals to minus 3. Now I directly put the value f of 0. When I directly put the value f of 0 here, 0 come along with 5 in place of x minus 3, that is 0 minus 3 again minus 3. This implies limit x approaches to 0, f of x is equals to f of 0. That means f is continues at x is equals to 0. Okay, so this is the very simple way which we have done in class 11th also. Okay, this type of question we have already done in class 11th. Now we will do the continuity at x equals to minus 3. So at x equals to minus 3, I will take the values at x equals to minus 3 again with the same function, that is equals to minus 3. How we can do that question? Again I will go through the first definition, not left hand limit, not right hand limit. I will take the definition of left and right limit when two different functions are given. Okay, so I will start with the limit x approaches to negative 3, only negative 3 fx, limit x approaches to negative 3 f of x. I will change the value by fx minus 3. Now I will put the value of minus 3 here, 5 minus 3 minus 3, that is minus 15 minus 3, that is minus 18. Okay, now I will take the direct value minus 3, that is 5 minus 3 minus 3. 5 3s are 15, 16, 17, 18, it will equals to minus 18. That means limit x approaches to minus 3, f of x is equals to f of minus 3. This means f is continues at x is equals to minus 3. Similarly, you can prove the question for 5. Same method, same way of doing that question. Now I will write the second question for you so that you can understand where we have to use left hand limit and right hand limit. Okay, I will take the ncert question of like that second definition. I will take the example for telling you how to solve the question by second definition. This is the sixth question of your ncert, that is fx is equals to, there are two functions, 2x plus 3 when x is equals to less than equals to 2, and second function is 2x minus 3 when x is greater than 2. It is given to you, and find all the point of discontinuity. Question says that find all the point of discontinuity, all the points of discontinuity. So how you can find, how you can solve it? I will tell you, when you have to use left hand limit, right hand limit, there should be two functions for less than and greater than. So I will opt for less than and greater than, two different functions. So start with the solution. I will take the left hand limit. When you take left hand limit, limit x approaches to 2 negative, I will take the negative value fx. Negative means you have to take the less than value. Limit x approaches to 2 negative, 2x plus 3. If I want to remove this 2 negative and 2 positive, so how you can remove? Limit h approaches to 0. When you write h approaches to 0, you will change x by 2 minus h plus 3. The function will be changed h. What is this h? This h is a very little amount, very very small value in the neighborhood of 2. That is very little value, very small value in the neighborhood of 2. That's why we have 2 minus h. This is the very small values. So I will put the values. Limit h approaches to 0 to 2 minus 0 plus 3. That is 2 2s are 4 plus 3, that is 7. Now I will talk about the right hand limits. How you can solve limit x approaches to positive. I will take greater than value. That is fx is limit x approaches to positive. This will equals to 2x minus 3. Up in this place, if I want to take h, so how you can take limit h approaches to 0? When h approaches to 0, this x will change into 2 plus h minus 3. Now I will put the value of h, that will equals to 2 plus 0 minus 3. That is the 4 minus 3 is equals to 1. That means no need to, these two values are different. No need to apply the third one for the equality. You can write it as left hand limit not equals to right hand limit. Therefore f is discontinuous at x is equals to 2. So this is the point of discontinuity is 2. So this is the way to solve the questions. Do the practice of this type of question. Thank you.